Hello coders, welcome to my channel. I am Aniket and today we will discuss question from GFG, that is check subset sum divisible by k. Let's read the problem. Given an array of positive integers and a value k, return true if the sum of any non-empty subset of the given array is divisible by k, otherwise return false. So if you are able to find any subset of the array which should be not empty, so if the you are able to find any subarray whose sum is divisible by k, so you have to return true, otherwise you have to return false. Like in this case, if you carefully see, this 7 plus 5 is 12 and which is divisible by 6, so that's why you have to return true in this case. And if you carefully see, you can't to find any subset of this array which give you that sum such that the if you divide it by k, you will get the modulo operation as 0. So what is the meaning of this? Sum of any subset modulo k should result into 0. That is the condition. If you found any subset, if you found any non-empty subset, then you have to return true, otherwise you have to return false. I hope you understand this. Now if you consider the constraints, the length of the array can be 10 raised to the power 3 and k is 10 raised to the power 3. So the expected complexity is n into k, which is easily acceptable. Now question arises that how can we generate all possible subsets? So the answer to this question is we can so answer to this question is we can generate all possible subsets with the help of skip comma pick logic. How it works? Let's see this with a test case. Let's say you have an array 1 comma 2 comma 3. So if you are currently at 0th index, then you have two choices, either skip it or pick it. So if you skip it, you will reach at 1 without any increment in your sum, and if you pick it, you reach at 1 with plus 1. Similarly here also, if you not pick it, you will reach at 2 without any sum, and if you pick it, you will got 2, that is the array of 1, and you will reach at 2. The same thing is repeated here also. Now for this 2 index you have two choice. If you not pick it, you will reach at 3, and if you pick it, you will reach at 3, but now the sum will increase by plus 3. Now here also the same thing repeat again. I hope you understand this. Now if you go from root to each leaf, then you will easily find the all types of subset sum. So if you go from here, then it is empty set, so that's why the sum is 0 in this case. If you go from if you reach from this root to this leaf, then the sum will be 3 only. And if you go from this root to this leaf, then the sum will be 2. And if you go from this root to this leaf, then the sum is 5. And similarly fill all of the sums. Now it is only 1, and it is 4, and it is 3, and it is now it is also 3. Now let's say k is given to you is 5. So if you find any number which is divisible by 5, you can return true, because it is the all possible types of subset sum. So if we find any number at leaf node which is divisible by k, we can return true. So now I hope you understand this question. And if you carefully see, there are many overlapping subproblems. So there is overlapping subproblem. So for overlapping subproblems, we should use DP. So use DP to get efficient, such that you don't calculate same thing again and again. You will simply store it into the DP table and use the stored result. Now let's discuss the various parameters that is useful for our DP state. So now question arises that what are the important parameters for DP state? Now the first parameter that is very obvious is ID, that is the index of the array you are currently at. Now the second important parameter is sum. So this is representing the sum of subset till ID. Now the third parameter is very interesting. So the third parameter is take. So it is representing whether you take at least one element of array or not. So if you take one element of at least one element of array, then its value should be 1. Otherwise its value is 0. So there are two types of value. One is 0 and one is 1. One is 0 and one is 1. Now the possible values of sum can be 10 raised to the power 6. Why? Because sum is representing the subset sum. So the size of the array is n, and each element of the array can store 10 raised to the power 3 numbers. So if you calculate this, the size of n, as I discussed in the constraint also, so it is also 10 raised to the power 3. So it is giving you 10 raised to the power 6. And the possible values of this id is n, that is the size of the array. Now if you calculate the dp table size, that is nothing but n into 10 raised to the power 6 into 2. So and 10 can be also 10 raised to the power 3 also. So if you calculate this, this will give us 10 raised to the power 9 approximately, but it is greater than 10 raised to the power 8. So that's why this will give us tle. This is giving us TLE. Now question arises that how can we optimize our DP state? So the answer to this question is we don't need the whole sum. We can work with sum modulo k also. It will do the same thing. Because of this, now the second parameter that is sum will changes to reminder, and for this reminder the possible values can be in the range of 0 to k minus 1 only, because you already know if you modulo any number with k, so it will result into 0 to k minus 1 range only. So now the updated complexity of the approach will be simply O of n into k approximately, and it is totally acceptable for our question. Many of you think that why I take this third parameter, that is take, or it is storing 0 and 1. Why I take these parameters? Because I take this parameter so that we will neglect our empty subarray. So we take this because we should we should neglect our empty subset. That's why I take this third parameter. Now it's best time to discuss the various DP transition. So let's say your previous state is id comma reminder comma 0 because you don't take anything initially. Now your next state will be of two type. If you pick this, now the next state is id comma reminder comma not reminder because you pick this, so that's why you have to add array of id and you will reach at id plus 1. So the next state will be id plus 1 comma reminder plus array of id modulo k, and the next state because you pick it, so now the value will become 1 because you pick at least one element, so that's why in pick case you have to do this one only for the take parameter and reminder plus array of id modulo k for the reminder parameter, and you will reach at the next index, that is id plus 1. What happen if you skip it? So if you skip it, you will reach at id plus 1 and your reminder doesn't change, and your this parameter, that is take and no take, will remain 0 only because you don't take anything. Or in more general way, if you keep this 0 also as take and keep this 0 as take, because if the previous take is 0 then it is remain as it is, and if the previous take is 1 then it is remains as it is. But in the pick case, this take case will changes to 1 only. I hope you understand the transition. Now let's discuss the code which do the same transition. But before that, please hit the like and subscribe button because it will motivate me to create such kind of intuitive video. Now let's discuss the code. So here is my Java code for the given problem. Firstly, I am initializing our this type of variables globally so that in the recurrence function we have limited parameters. So n and k is defined globally, the array is defined globally, and the dp table is also defined globally. So in this initialization we store all of them, that is this dot array is equal to array and this dot k is equal to k. It is very simple thing, and we initialize our dp of boolean type of the size n and k plus 1. And firstly I will take a boolean variable boolean array, that is take, which is of size 1, and initially it contains false, which is representing the empty subset. And if you pick any element into the subset, then this take will become true and never become false again. And this updated approach will give me O of n into k complexity, not O of n into k into 2 complexity. So that's why I take this uh, boolean data type boolean data type array, that is take in separately. Now before discussing the base case, let's discuss the body of this recurrence function. Now if you skip it, you will simply go to id plus 1 and the reminder doesn't change, and the take is representing the boolean array, so it is same as it is. Now if you pick it, now you have to convert your take 0 to 0 to true. That means we have picked at least one element. So that's why in this case the take 0 will becomes true. Now you will call memo of id plus 1 comma reminder plus array of id modulo k comma take, just like as I discussed before also in the in the transition diagram. And we will use this or operator, which means if either if any one of them is returning true, then the answer is true. Then the answer is true. I hope you understand it why I take this or operation. And we will simply memorize it so that we don't calculate same thing again and again for the parameter id comma reminder. So if we calculate id comma reminder initially, then we use this value from the stored value, that is dp array. So we can infer this value from the dp array and don't calculate it again from the our recurrence. I hope you understand it. This is a standard approach of dp with memoization. And in the base case, I take this reminder modulo k is equal to 0, and you pick at least one element, then only you have to return true, otherwise you have to return false. If you reach at the last index, that is id equal to n out of the bound of the array, in that case you have to return false, because you don't find any subset which is giving you subset sum modulo k as 0. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button, because I regularly make such kind of intuitive video for you. Thank you for watching my video.